virtual local area network is a logical group of workstations, servers, and network devices that appear to be on the same local area network despite them actually being geographically separated. Essentially, it allows users to communicate in an environment as if they were attached to the same wire, sharing the same broadcast domain. The main reason of implementing a VLAN is scalability, security, and ease of network management. Let's go into this a bit further. As a network administrator, you may want to apply additional security to certain types of communications, and this VLANs is an easy way to do so. It provides a simple model for relocating network devices. Along these lines, it adds flexibility to devices that are located in different areas. Maybe that's a different floor. Maybe that device is on a different floor in a building, or it could be across the country in a company's remote office, but the two devices would still communicate as if they were on the same wire. VLANs also decrease the latency and traffic load on a network. Now that we have refreshed ourselves on what a VLAN is, let's move to the best practices for a VLAN. In most cases, you'll be using Cisco switches in your network. Not always, but it is very common. And when you get a new switch, it is pre-configured with default configurations that need to be changed. The default Ethernet VLAN is VLAN 1. It is a security best practice to configure all the ports on all switches to be associated with VLANs other than VLAN 1. This is usually done by configuring all unused ports to an empty VLAN, parking lot VLAN, black hole VLAN. These are all terms you may have heard before, so no one can use them on the network. All used ports should be associated with VLANs distinct from VLAN 1 or your quote black hole VLAN quote. It's also a good practice to shut down unused ports to prevent unauthorized access. As I mentioned earlier, there's different types of VLANs, and it's best to separate the traffic that goes over these VLANs into multiple VLANs, but you'll normally have a management VLAN and user traffic VLAN. The management VLAN, which is by default VLAN 1 with Cisco, needs to be changed in order to prevent people from accessing your management VLAN just by plugging into the switch. When communicating with a Cisco switch for management purposes, the switch must have an IP address configured on the management VLAN. Users in other VLANs would not be able to establish remote access sessions to the switch unless they were routed into the management VLAN, providing an additional layer of security. Also, the switch should be configured to accept only encrypted SSH for remote management traffic. All of our controlled traffic is sent over VLAN 1. Therefore, when the native VLAN is changed to something other than VLAN 1, all controlled traffic is tagged on 802.1q VLAN trunks. It's recommended security practice that we change the native VLAN to a different VLAN. The native VLAN should also be distinct from all user VLANs. Ensure the native VLAN for 802.1q trunk is the same on both ends of the trunk link. Now let's go into DTP. Dynamic Trunking Protocol offers 4 switch port modes: access, trunk, dynamic auto, and dynamic desirable. General guideline is to disable auto negotiation. as a port security best practice, do not use the dynamic auto or dynamic desirable switch port modes. Lastly, voice traffic has stringent quality of service requirements. If a PC and IP phone are on the same VLAN, each tries to use the available bandwidth without considering the other device. To avoid this conflict, it's best to use separate VLANs for IP telephones and data traffic. Let's recap. We talked about the best practices for configuring networks using VLANs, such as changing default configurations, for example, out-of-the-box switches, the common types of VLANs that you'll use, and we went a little into VLAN trunking and the best practices for setting up VLAN trunks. Next, we will move on to securing your VLANs.